Okay, hope everybody's doing well today. This is going to be the fourth video in our Regression Using R series. So today we're going to talk about mean centering predictors and how to interpret those results. And in our previous videos we covered simple regression, multiple regression, and adding categorical predictors. So again, today we'll go over mean centering predictors, and then we'll look at how to add interaction terms and run moderation analyses. So as usual, we'll start with running our code. Now just to refresh, in case you haven't looked at the other videos, this is a data set where we're predicting turnover intentions for employees from a variety of different variables. So basically we're looking to see employees' desires to leave their job and whether or not that can be predicted from a variety of variables. And then the data set can be found in the links here, and then on my GitHub page I also have the links in the description of this video. So the first thing we want to do is to load all of our packages. We won't use all of them for today, but it's good just to go ahead and load them because we use them in the other videos. And I'm going to go ahead and load my data set. And so again, we have our turnover measure, which is our turnover intentions, which is our outcome measure, and then we have our different variables. So previously we've ignored what these centered versions of our variables mean, and today we're going to finally talk about what that means. So the first thing I'm going to do is I am going to go ahead and convert my categorical variables to factors. We won't need that for this particular video, but I discussed this in our previous video on adding categorical predictors. That's always something you need to do, so I'm going to go ahead and do it, but don't worry about that for this video. So I'm going to scroll down to the mean centering section, if I can ever find it. Here we go. Alright, and so today we're going to look at simple regression first with just one mean-centered continuous predictor. So we're going to predict turnover intention for pay satisfaction, but we're going to mean-center pay satisfaction. I'm going to show you how to do the code first, and then I will go over the interpretation. This will be a really quick video relative to the other ones. And so the first thing that we're going to do is we might want to look at a scatter plot of turnover intentions and mean-centered pay satisfaction. So let me just make that note real quick. And so just like before, you just specify your data set, then you put in your centered variable, and then you put in your outcome measure turnover intentions. And also, real quick, I will show you how to quickly mean center your predictors if you don't already have them mean centered in your data set like I do. Okay, so if you want to mean center your variable, all you do is you make or you designate the name for your new variable. So for us, we're going to mean center age, so we'll just say dat1 tilde the name of our new variable, which is age center, and then we're going to use this operator to save that as the scaled version of the raw age variable. So again, I'm just scaling using the scale function the original variable, which is just the regular version of age, and then you have to specify scale equals false if you just want it to be mean-centered, because by default R will also standardize this. It'll divide it by the standard deviation. So you specify scale equals false. So I know that seems kind of weird because we're using the scale function but then saying scale equals false. Well, the reason why is because we just want it to be mean-centered and not standardized as well. So let's go ahead and run this. And now let's take a look at this variable to make sure that it came out correctly. Okay, and as we can see now, the mean is 0. So this makes perfect sense because again, the whole purpose of this when we're mean centering something is to subtract the mean from every single individual observation so that your overall mean goes to 0 instead. And one other thing I'll do real quick is I'll show you a comparison of the difference between the raw variables and the mean-centered variables. So I'm actually going to look at a different variable. I'm going to look at pay satisfaction raw, and then I'm going to look at the pay satisfaction centered version. And so here we see that the mean pay satisfaction level for the raw variable is 3.37, and then when we mean center it, now the mean is 0, because again, we've just subtracted the mean from every individual observation. So that's what mean centering does. Just wanted to explain that. And then also we can see that our standard deviation did not change, and that's how we want it to be. If you want to also standardize, then you would just come up here and you would specify, you wouldn't need to specify that scale equals false. You could just say scale and then your variable. So again, that's the difference between mean centering and standardizing. Mean centering, you're not touching the standard deviation, whereas when you standardize, you're also dividing your new variable by its standard deviation. Okay, so anyways, now that we've covered that, we'll take a look at a scatter plot of turnover intentions and our mean-centered pay satisfaction. And so again, we just type in our data set, then we type in our centered variable, our centered X variable predictor, and then our outcome measure. Okay, and now I'm going to come down here and add the regression line. I'm going to add a title, zoom in, and so now what we see is if we look at our scale for pay satisfaction centered, well, it ranges from -2 to +2, and the mean is 0. Whereas before, it ranged from 1 to 5 because that's how it was originally measured. So just wanted to give you a visual demonstration of what mean centering looks like. It doesn't change, the relationship between these variables. It just changes how we are measuring pay satisfaction, the scale that it's on. And so really the steps for doing the regression are exactly the same. The only thing that's going to change is our interpretation, which we'll talk about after we fit our model. So we're just going to come here and we're going to say M1 cent, which is our centered version of our first model, LM, and then your outcome measure, tilde, your centered predictor, so pay satisfaction centered, and then the name of your data set, so we'll fit our model. We'll come and get a summary now. Let me make this easier to see. And so here is, as always, our estimates, which is our intercept and slope estimate, and then the significance test. So it looks like pay satisfaction is a significant predictor of turnover intentions, and we'll go over the interpretation of the slopes in a little bit. If we want to get a confidence interval for the unstandardized slopes, we just do conf_int and then the name of our model. And there it is. If we want to get a confidence interval for the standardized regression coefficients, there it is. And then if we want to get a confidence interval for the R-squared, what we have to do is we have to type in by hand what our model R-squared is and then what the degrees of freedom for the F test were, or the F statistic rather. So let's go back up here. This is where we get our multiple R-squared for our model. Again, we got this from the summary of our regression model. So I'll change this. And then this is where we put in the degrees of freedom. So come down again to your model summary and it tells you these are your degrees of freedom. The first one is 1, the second one is 1452. So I specified df.1 equals 1, df.2 equals 1452. I'll run it. And then here's our confidence interval for R-squared. And then if we want to get a slightly prettier version of our table, we can do outreg M1 cent, which is the name of our model, and then type equals HTML to get an HTML table. And so when I run that, we get a slightly prettier version of our model summary where we have our estimate for our intercept and slope, the standard error in parentheses, and then the asterisks denote whether or not it was significant. And then our R-squared, the number of observations, and so on and so forth. Okay, and then as before, we can get our check our regression diagnostics and get our residual plots by doing plot and then the name of our model. And I'm going to type in ask equals false, so this way it's a little bit of a shortcut. So we'll do this, and then we have all of our different residual plots. And we can scroll back and forth using these arrows. And again, I'll go over how to interpret that in a little bit. And then a slightly prettier version of this same thing is we can run this code, again, where all we're doing is typing in the function and the name of our model. We run it. It takes a second, and then we see down here we have some prettier versions of our plots, our residual and diagnostic plots. All right, so that's how we run the code. So again, just to recap, if you already have a centered version of your predictor, then nothing changes. You just run the same stuff as with your original variables, but this time sub in the centered predictor. And if your data set does not already include the center version of the variable, then you just come up here and create a new variable that's a centered version of your original variable by scaling your original variable and setting scale equals false to note that you do not want the standardized version, you just want the mean centered version. So really, really simple to run the code, and now we'll talk about how to interpret the results. Okay, so coming back to our PowerPoint to talk about our results. And here we have the mean-centered version of turnover predicted from mean-centered pay satisfaction. So again, this information just came from all of the code that we looked at before. All I did was plug in the information. Okay, so how to actually interpret the results. This is just the same thing as what we just saw, except now I've just highlighted the intercept. The reason I highlighted the intercept is because this is all that changes when we mean-center predictors. Let me repeat that. There's a lot of bad information out there. Mean-centering your predictors does not do anything except change the intercept. Okay, so we see right here that this is the raw estimate for our intercept, and what this tells us is that this is the predicted level of turnover intentions for individuals with average levels of pay satisfaction is 2.12. Now the reason that this changed is because remember, our intercept always tells us the predicted level of our outcome measure when our predictors are set to 0. Well, we saw from our descriptive statistics a minute ago that when you mean center a predictor, guess what its mean is? 0, right? Because you're subtracting the original mean from every individual observation. So now the mean-centered version of a predictor has its own mean of 0 now. So let me repeat that. Because your intercept is the predicted outcome level when your predictor is at 0, and the mean-centered version of a predictor has a mean of 0, the interpretation of the intercept in a regression model with a mean-centered predictor is such that the intercept tells you the predicted outcome level for individuals with average levels of that predictor. So in this instance, it's the predicted level of turnover intentions for individuals with average levels of pay satisfaction. This is the key difference in mean centering and non-mean centering, right? The reason why you might want to mean center is because this can be a lot more informative than the intercept is when you just have like a non-mean centered version of a variable. So in this instance, right, we might be more interested in what the starting level of turnover intentions is for the average level of pay satisfaction, and we might not really care about what the predicted level of turnover intentions is when pay satisfaction is 0 for like the regular version, right? As another example, think about if you're predicting height from weight. Well, if you have your regular version of weight, the intercept tells you the predicted height for someone with a weight of 0. No one has a weight of 0. That's impossible. So if you mean center weight, now your intercept is meaningful because it's the predicted height for someone with an average weight. So again, the reason why we might want to mean center predictors is to make our intercept more interpretable. And a lot of times you'll find that it does make more sense to mean center your predictor for that very reason. But I want to emphasize that it does not change the slope or the relationships, right? It's just changing the intercept. And so the way we would interpret our slope for pay satisfaction centered version is just the same. For every 1 unit increase in pay satisfaction, turnover intentions are predicted to decrease by 0.41 units. And real quick, I want to go back to our original prediction of turnover from pay satisfaction before we mean centered pay satisfaction and look at our slope. It's still negative 0.41. And now we're back to our centered version, and I just wanted to again explain that the slope didn't change, it's just the intercept. And then for our standardized regression coefficient, for every 1 standard deviation increase in pay satisfaction, turnover intentions are predicted to decrease by 0.34 standard deviations. Again, that interpretation didn't change either. It's the same as it was with the non-mean centered version of page satisfaction. And same thing with the multiple R squared. This also holds when we have multiple predictors. Again, the only thing that changes is the intercept. So if you have more than one predictor, then your intercept, if you have mean centered both of those predictors, would just tell you your predicted outcome measure for average levels of both of your predictors. And so that's pretty much it for mean centering predictors. Again, this was a shorter video because literally nothing changes except the intercept. I just wanted to show you how you would mean center your predictors, how you would run your code to run the regression model with mean centered predictors. Again, nothing changes except for the intercept. So yeah, it can be a really useful thing to do when you are interested in having information about your outcome measure at the average level of your predictor levels. Thanks for watching the video, and as always, please subscribe, and you can check out my GitHub page for links to the code and the PowerPoints today. And if you have any questions, please leave them in the comments. And then in the final video, we'll talk about adding interaction terms and running moderation analyses. Thanks, and have a great day.